Hi, I'm Richard, and in today's tutorial we're going to be creating 2D super shapes. So let's get started. Hello and thank you for watching, and today what we're going to be doing is we're going to be doing what's called creating a super ellipse, and that's this thing here. We're going to be taking some fairly small steps. What we're going to do is we're going to initially just create a very simple, if you like, sort of, what do you call that, morphable circle that goes sort of inwards, and then a nice circle, and then gets beveled corners like that. Then what we'll do is we'll work towards this guy here. He's called Daniel Schiffman. I've mentioned him in a video before. He's actually created a few tutorials on Supershapes, and he's using Java, so we're going to be creating this in Unity. These things here are called Supershapes here. This is all very 2D, as you can tell, but the ultimate goal is to go over to here and create these what you call sort of 3D morphable Supershapes. So what we'll do is we'll be actually creating these in Unity. I hope it's going to look super cool, but we're going to take fairly small steps. What we'll do first of all is we'll work on getting these pieces here, these Supershapes in this tutorial, before we crack on and create these really weird looking I don't even know what you call them, but all these crazy algorithms that are going to create this effect here. So let's get started. So what is a super ellipse? Well, before we even go down that path, let's very simply work out how we're going to create a very simple circle, a simple 2D Unity circle. We'll do it in 3D. But what we'll do is we will use a line renderer. So although it's a 2D circle, we're still working in 3D space. That'll mean we won't have to sort of switch between Unity 2D and 3D. So let's get that started right away. Let's go and create a new project. So let's do that now. File, new project. And what should we call this? Now, I've already created one called SuperEllipse because I was playing around. So let's call this SuperEllipse tutorial. Make sure 3D is selected and click create project. I'll let that crack on. Let me hide that man there. Let's just show you the super ellipse here while that's loading up. This is the sort of effects you can get. You can see it when it's less than 1, when this end value is less than 1, and you get this sort of inward looking, I don't know what you would call that. What does it even say here? Super looks like a 4-armed star with concave inward sides. There you go. And as you approach 1, it gets more cylindrical, and then as you go above, sorry, 2, excuse me. As you approach 2, it gets more spherical, round, and then as you approach, as you hit more than 2, these edges become more and more beveled, as we saw a few seconds ago. But before we even go down that path, let's create a script that's just going to give us a very simple circle. Now we're going to use a line renderer just to get us started. It's a very simple Unity 3D object. It's an object, it's a component, isn't it? It's a component of Unity, and what it does is it takes an array of positions of vector 3s, and it draws a line from along those vector 3s. So let's first of all create a new script. Create C# script, and we're going to call this SuperEllipse, like so. Alright, so with that done, let's just double click that and go into it. Super. Okay, so what I think we'll do is in our start method we'll just create a call to a function called create. Let's call it create superellipse. I know it's not a superellipse right now, but we'll adjust the function. Is it functions in C# or is it methods? I know it's methods obviously in Java, but I'm not sure in C#. Somebody please let me know. So what we'll do is we'll create superellipse and we'll give it a radius. So let's just say the radius is 4. No, let's say it's 10. Say it's 10. Let's see how that pans out. And not here. No, we'll keep update there. We just won't do anything. And down here we'll just have a void create super ellipse float. Yes, float radius. All right, like that. And now what we need to do is we need to create a set of points that the line renderer will use. So let's just have a little think about how we can do that. In fact, what we should probably do up here is have let's just call it, we won't make it public just yet. We'll just have an int num points, and we'll set that to 20. And then what we need to do a bit of old school maths here. If you've ever, I know actually I'd probably encourage you to watch Daniel Schiffman's videos, because they really do cover this very well, and I'm going to do a much better job of explaining this than I am. But using a little bit of sine and cosine, you can get for any given point from a center point along a radius, you can get whereabouts on an xy graph, if you like, whereabouts that should be plotted. So I'll just run through this, and if this doesn't make any sense, don't panic. I had to copy this myself. I highly doubt I could ever have worked this out without somebody like Mr. Schiff. And of course, all of this stuff is, I think, in fact, if I spin here, it's probably now this is actually the SuperEllipse. So it goes into this bit here. So we won't talk about that just yet. We'll just create the actual circle itself. And the way we're going to do that is you're going to say something along the lines of float xpos equals radius, and what else do we need? First, the other thing we're going to need is a number of points that we're going to create along this line here. So let's just do that now. So we'll say, we know how many points we're doing, don't we? So we'll say for brackets int I equals 0, I is less than num points, I plus plus. And in order for us to kind of work our way around a circle, we'll need to use something like pi in order to calculate the value. So what we're going to actually say, so let me just think about this. What we're going to say is the increments in terms of how often this thing goes, how many sort of angle increments each point is along this circle. So what we should probably need to do is say something like float increments. So you could almost call this angle increments. Angle increments equals, and you need to say 2 pi, because we're going pi is just a semicircle in this logic. So we need to go 2 pi. Mathf.pi. Is mathf.2 pi there? No, so just say pi times 2 divided by the number of points. Okay, so what we're saying here is that we're doubling pi, and we're saying, right, divide that now please by the number of points around this circle. So if we had 50, then it would create 50 points around the circle. Again, if it's not making complete sense, don't panic. It's just that little bit of maths that you're going to have to suffer. And what we're going to need to do as well is going to have actually saying float angle equals 0. Okay, so we'll start at 0, and then for each iteration in I, we'll increment the angle by angle increments, which should get us near as damn it a full circle. Let's have a little play. So what we now need to do is say float xpos equals radius times mathf dot cosine of the angle, and float ypos equals radius times mathf, I think it's dot sine of the angle. And we need to store that, but before we finish the loop off, we just need to say angle plus equals angle increments. Alright, so it's going through, and it's going up and up and up, and eventually it will get close to 2 pi, and that should give us all of the points around a circle. But we're not storing them at the minute, so that's absolutely no good whatsoever. So let's create an array. Let's do that up here. So we'll just create a, no, not there, that's for the start thing, isn't it? So we'll say here vector 3 points. And then down here, I think we just very simply say points equals new vector 3, and obviously num. I say obviously a lot, and you're thinking, well, it's not obvious, Richard. So I'm sorry. There we go. So we're going to create a vector with the number of points that are created, so we can store them in this value here. And all we now need to do here is say vector 3, not vector 3, points I equals new vector 3. Xpos, ypos, 0. Remember, we're only doing this in 2D space, so we can just ignore the z-axis for now. Alright, we could have done this in 2D. Right, so now what we've got here is an array of points around a circle. That's good stuff. And then we'll want to use that line renderer to create those points. So let's just Control S here and spin back into Unity. And what we'll do is we'll create an empty object. What should we call this? We'll just call this a game object is fine for now. And in that case, let's just reset its position as well. And then here we'll add a line renderer. In fact, there it is. So if you just type it in, just type line renderer. Okay. Without wishing to go into too much detail, a line renderer can have materials, and you can do a lot of stuff with line renderer. But we're not going to do that today because we're just, if you like, proving the concept right now. But the key one here is the positions, and you can set the size and these vector 3s here. All right. So what we're going to do is we're going to do that in code. So if we go down to here now, if we say, so let's go up here, and we'll have a public. No, we won't. No, we won't. We won't, because we'll keep this script in the same object as the line renderer. So we'll just say line renderer. There we go, LR. And here we should be able to say LR equals get component. There, line renderer. Okay, and provided it's in the same object, which it will be here, so we can even drag this in now. Can we? Drag in. There we go. We've got any errors? Not yet. Okay, so because this script is in the same game object as the line renderer, it's gonna be able to reference that. All right, and so now what we can do, if we go down here, I hope. So we say lr.set vertex count to num points. That's the number of vertices, and we should be able to say lr.set positions points. Maybe we should have called that positions, not points. Okay, good. Should we try it? All right. Now, I guess the trickiest bit of maths probably for you guys is this piece here, and this mathf.py, and it took me a little bit of time to get used to. But if you dust off your books on trigonometry, and in fact this is actually quite a fairly well-known equation to sort of position points around an XY graph. All right, so if you, like I say, if you're not too fussed about trigonometry, just trust me that this bit works. If you are interested, then I say go and have a word with your old maths teacher if they're still alive. All right, so let's save that and let's try running it. There's no errors. Let's give it a quick run. And look at that, that's worked straight away. Slight problem is that it hasn't joined the last piece up, and I think that's because it'll never quite join the last one up. So because it's probably gone less than 1. So what potentially we could do is just say num points plus 1, and then what we're going to do here is we'll create a vector 3 initial pos, and you have to define it. Oh, do you have to define it? Let's just leave that. Okay, and then in here we're going to say if brackets I is 0, initial pos, I'm not sure if this is the right way to do it, equals points I. Alright, so we're going to assign it to the very first point if it is the first point, and then I think what we can do down here, we've set the number of points size plus 1. That's it. So now we just say here, we're going to say add one more point, lr dot, no, not lr, points, num points. Okay, so this is the last point, equals initial pos. All right, so what that's actually saying is, join up the very last point should be the first point. All right, so if you imagine that would just kind of tie things together at the end. Let's just see if that works. I'm winging it a bit here. Let's just see. All compiler errors must be fixed. Yes, because this needs to be assigned, does it? Where's that initial pos? Is that the problem here? Use of unassigned local variable initial pos. Why did I put it there? Have I spelled it the same? Maybe it needs to be assigned. Let's just try that. Vector 3 dot 0 0. All right, how's that looking? Now let's try it. It's gone away. Yeah, so you can't. You have to assign these variables. I think these are called. What are these called? They're not classes, are they? They're value variables. Let's save this. Actually, that's a good idea. That while we're at it, let's just call this main. All right. In fact, what I might do as well, just to keep things honest, is I might create a folder and call it scripts, and just drag main into scripts. This is all fine. And now let's run it and have a look. And that has not worked. In fact, it's saying index out of bounds. So let's just check why that would be. Equals new vector 3 num points plus 1. And that's saying num points. Where's that index out of bounds? It sure enough is there. Points. That's going to be num points plus 1, isn't it? Okay, yeah, because the vertex count needs to match the points up here. So let's try that. Teething problems. bang, and there's still a little bit of a gap, but we don't care. 20 is actually not the greatest, is it? What we can do as well while we're at it, so if we just get a position in front of us there, if we just click on main camera and then click game object align with view, that will make our camera point in the same position as our scene view. But here's the thing: as soon as you stop it, that camera position will be reset. So what we'll do is we'll just click here and do copy component, and then when we stop it, you see it all goes back. But what we'll do now is we'll say paste component values, and now if we run it, there you go. There you go. So that's good enough. Okay, so we've got ourselves a beautiful looking line renderer. Okay, but this is good, but it is just a circle, and there's nothing we can do with it unless we start playing around with this super ellipse value here. And it's not as bad as it looks. Okay. Again, this is where Daniel Schiffman is. Now, where's the actual equation that you can use? It's around about here. Here we go. So this theta here. I'm going to zoom in on this. This little 0 here with a line across it, if you like, is considered to be the angle. Okay, and we've got a couple of variables here, a and b. These represent the radius. We've got two radius values now, so you sort of, one's the horizontal radius and one's the vertical radius. So you'll see that if they're different, you'll get a sort of a more flat circle. All right, so it's not terrible. And we can work through this, and what is best is if rather than just trying to explain it, because I'm not sure I can do the best job of explaining it, is if I very, very simply copy the equation into something that's in a readable format in C#. So let's just spin back into here. We'll stop that and go over to here. So rather than have these two values here, we're going to go a little bit further. We're going to say, so let's comment them out, and that one. Okay, so I'm going to type these in, and you're going to just bear with me while I do it. Well, let's just have a little look, because we've got, I hope you can see that we've got things like power of n's there, right? The power of n, x over a to the power of n plus y over b to the power of n. All right, and so we can spin through here. Just to very, very simply decode that, we're going to say float x pos equals, on the other thing, by the way, the other thing just to bear in mind, I've noticed there's a sine symbol here somewhere. Where's that sine symbol? Here it is. Yeah, can you see this sine here? Sine of cosine 0. So what that actually is saying here, the sine is a function that you need to write that says if the value is less than 0, return -1. If it's 0, return 0. If it's +1, return 1, I think. It's the other way around, sorry. If it's 1, if it's greater than 0. Okay, so we need to create a little function here that just checks to see what value is being passed in and returns -1, 0, or 1. Alright, so this is looking pretty horrifying, but it's not as bad as you think. So let's just write this in, or maybe you don't think it's bad. Maybe you're thinking, Richard, stop spoon feeding me. It took me a while to get the hang of this, that's for sure. So let's just try this. mathf.pow, and we're going to use an absolute value of, here we go, the cosine of the angle to the power of NA. So let's just do NA. What is NA? Hang on. 2 over n. So let's just say up here, we'll just do this. We'll say float NA equals 2 over n. And we do need to set an n value, don't we? And n, I think, is actually the radius. So we'll just change that to n, like that. It's equivalent to the radius, I think, is what we're saying here. It's a value that we're going to pass in. That'll make a bit more sense in a minute. And that's what let's say. I think if you go down here, you can see the n is changing. That's the value that changes. Bear with me, people. This will all become nice and friendly very, very soon. So we're going to say NA over 2. So there we go. So now we've got math to the power of NA times A times this function that we're going to call SGN. Again, we haven't got A assigned, so let's just put that up here. A is like the radius again, I think. So we'll just have float A equals 10f. We're also going to have to create a B as well. So that'll be a bit more sense in a minute. Times A times mathf dot. No, sine is going to be the function we write, isn't it? So let's quickly write that down here. So it's int SGN float val. And then here we say if brackets val is less than 0, return -1. Else if val is greater than 0, return 1, else return 0. Alright, so that's the sine function here. Where's it gone? Where you gone? Where did you go? Here, that's the sine function here, okay, -1, 0, or 1. So to me, this is very mathematical. If you're a programmer, this is thinking, what is this? But it's actually just a mathematician's way of drawing these functions out. All right, so we can go back up here again. Say sine of the cosine of the angle. Mathf dot cosine. Yep. Angle. Brackets. Semicolon. Does that work? It does. So now all we need to do for the y, what we need to do is change it to ypos, and that's math.fps, and we use signs for the y value, and b. I don't know why we need to put a and b, but we're going to do b. We could just have that as one single value, and now we've got ourselves a rather funky looking value. A little bit more confusing, and you're thinking, well, what's the difference going to be? Well, let's take a look. It's compiling still. Let's try. Any errors? No. And look at that, we've got ourselves a beveled square. So let's try and see why that is. I was kind of hoping that would be a perfect square. Maybe it's because I need n. Where is n? I've put 4 here, haven't I? I wanted to end 10. Look, I want that to be 2. Alright, so let's just run that again. 2, if we just check here, I think it's about here, look. Here, where is it? Yeah, as you approach 2, alright, it's going to look more like a circle. So let's just try that. Bang. In fact, let's up the number of points as well, shall we? Let's put that up to 50. There, that's nice and clean, isn't it? But okay, you think, well, that's good, but that's just looking like the circle we had before, and all you've done is create some massive looking function. And here's the magic. What we can do, I think you just saw that there, was if we do 4, now all of a sudden we're getting something that's more rounded. And if I just do 1, okay, so we're changing this value of n here. Okay, this is the, and where is n? Where is n in this equation? Yeah, there we go. NA is 2 over n, you see. So it's creating this different values based on that power thing there. So if we just do 1, do I click it? Yes. It's almost like a diamond, isn't it, with a slightly messed up end there, but that's all right. Let's do 0.5. Click it. I've probably got to do it 0.5f, right? There we go. When you're ready, thank you. And we get this value. Okay, that's good. Why don't we make it? Why don't we just get a bit all unity on it and make that a slider that we can adjust? This should be quite straightforward. We will, excuse me, we'll add a thing here. We'll add a slider to the UI. So let's just create that. Create a UI slider, and it creates this enormous window. I've never worked out why that window is so large. Just go to game here, just see if it's there. It's not. So what you can do, if you just click on the slider, click on this, hold Alt. And you can choose the position you want to put, and it'll put the anchor and the UI object to wherever you click. So let's just click there, and you can see it's gone into the bottom left-hand corner, bottom middle, excuse me. And if I just go over here and drag it up a bit, why don't you come there? Something like that. That's fine. And we'll just set these values to the minimum value is 0, maximum's 10. Let's say 10. Yeah, 10's fine. Whole numbers, and we'll set it initially to 2, shall we? And then what we can do is we'll have to add a listener to this to say that whenever it changes. So I think what we'll do here is we'll have a reference to that slider. This will have to be public, so we'll drag it in. Public slider is not there, so we'll have to add the unityengine.ui using, there it is, and now we can say public slider. Is that right? Let's try it. Slider. I think what you need to say, it's a bit of a messy one, this, I think. Create SuperEllipse. Let's just set that to 2. Let's set it to the same value as the slider for now. No, we won't. No, we won't. No, we won't. What we'll do is we'll say slider dot on value change. What we have to do is we have to add a listener to it, and it's add listener. I think you do something crazy like a delegate good. And that has crazy. Yeah, this bugs me. Create SuperEllipse. This is the method it's going to call, and from that we'll get the slider.value. All right, so we'll set whenever the slider changes, call this method with the new slider value. I think that's it, and we'll have to add brackets and semicolon there as well. Does that make your head spin a little bit when you see curly brackets inside method calls? And what we'll do here actually is we'll just say slider.value. Okay. And what we'll then have to do in our script, where are you, script? Where'd you go? That's the slider. So in the game object here, there's a reference to that slider now, so we'll just drag that in. If I've got this right, which you never know your luck, I can start pulling this thing around. Look at that, and start. Fantastic. So we've got something that we can actually tweak around there. Is that cool or is that cool? It's cool for a bit. You'll get bored with it after a while, especially when it reaches 0. Look at that. Interesting. You say I'm actually looking at the positions here. You've got some not a numbers. It doesn't seem to error. Oh, it does. Look, invalid. No, I think that's invalid. AABA. Boo. Ooh, I don't know. Let's have a look at the console. I don't know what that means. I suspect that's probably something to do with the fact that that was not a number. Let's just clear it. I'm playing here. I need to be careful. Let's just do that. Everything's happy, but when we go to 0, yeah. So okay, it's kind of expected. It's trying to divide by 0, so it's getting all sorts of nasties. But the good thing is it's not crashing on us, and we can keep tweaking that. All right, good. But this is good, but we can improve. We're not going to move on the 3D stuff yet, but we are going to look at the super ellipses to create these crazy shapes. I think if we go, where is the super ellipse? It's in a separate one. I'll find that Wikipedia page. 1 second. Okay, here it is. And if you were horrified before, how about this one here? That looks pretty mean, doesn't it? I don't know what to say to you other than we're going to need Mr. Schiffman to help us out on this one again. It's not as bad as it looks once you actually break this thing down, or at least can talk to somebody that's able to break it down. This looks like a square root here. It's actually what's called the nth root. So n being, it could be 3 or 4. If it was 2, it would be the square root, but it would be the nth root. And we've got some cosines here of angles, and we've got some new values. Look, m and n. A and B, I think we're already there, but so we've got M and N as well. If I can't see A and yes, I can see B. There's B and M and N. All right, N1, N2, and N3, and R. So let's code that in. Let's just see how that works. 1 second, I'll grab that code and start typing it in. But you can see, look, if you do different things here, look, M3 and M is 4, M is 5, and you can do some really cool stuff when I think if you change some of the values. There you go. You see, if you change some of them to like N1 is 0.2, some pretty cool stuff. So we'll have a little play around, but let's get the formula into Unity first. Okay, let's just double check I'm recording. Yes, I am. You can still hear my dulcet tones. So we're actually going to, let's just comment this out now. And what we'll do for this one, I think, is just go back to the radius. So for the radius to work here, what we actually need to do, let's spin back over here. Is we need to find the radius based on this value here. See, the radius is going to change depending on sort of the angle, the position as we rotate around the circle that we're going to be. So what we're going to do here is we'll say, so we can say, in fact, we can use this again here. And what we'll have here is say radius, float radius equals SuperShape bracket SuperShape brackets angle. All right. Okay, so we need to write this new method called SuperShape, and it's going to give us, depending on the angle, and then we can use this same formula back here to say what that's going to be. Okay, this is a pretty good start. So let's just comment these. We can keep A and B. We know they're still going to be there. Number of points is good. Yeah. Okay, this is fine. All right. So what we need to do now is just create this value called SuperShape. And I'm going to literally rip this off. So this is going to return a float, isn't it? SuperShape. Brackets float angle. And let's have a little look at the code here. 1 second. Where did it go? It was here, and it was here. So we're going to call, what he's done is he's broken it down to pieces. Theta, what is theta? Oh, theta is the angle. Okay, he's called it theta here. Times m divided by 4. So just have a little look at m. M is 5, A is 1, B is 1. Well, we got A and B as 10. And we've got n1, n2, n3. I think they need to be the same as well. So let's put those up the top. So float n1 equals 1. I'm just going to float n2 equals 1, and float n3 equals 1. And then what was the other one? It was m, wasn't it? Var float m equals 1. Why is that not working? There we go. Float a and b. Okay, so for now we can tweak these values in a minute. I think that's all. I said m is 5 there, so let's just set it to 5. I think these ones here you can play around with. Okay, a and b is, I think a and b is the actual kind of radius, so we'll keep that as 10. I'm not sure what the oscillation is there. We'll come back to that. So let's try that again. So what we've got here is a float. We'll call it float part 1. Where's our here it is. Float part 1 equals. Let's just copy that, shall we? In fact, let's copy the whole thing. Let's copy the whole thing and see how far we get. So if we change that to theta, which I'm going to call the angle. All right. So let's do that. This is, oh, do you know, I do. So let's just do Control X there, and then Control X, and then Control Z. This annoys me. This is Control C, and now if we do Control V, I think this is a bug in Mono Develop. It doesn't let you copy and paste. Float part 1 equals 1 over A times that's going to be mathf dot cosine of brackets theta times m divided by 4, and that's going to be mathf dot abs, absolute value there, and mathf dot pow of part 1 coming into. Are we off to a good start? Why aren't you working? mathf dot abs brackets part 1. Let's just Control S. So why aren't you why are you saying this to me? mathf dot abs there. Well, he's just being a monkey. Right, okay. Part 1 and pow, stop it. I'm going to assume that's working. And then part 2, which is also going to be a float, is 1 over b times mathf dot sin theta times m over 4, and then here we go, mathf dot part mathf dot what was it, abs, like that, and then mathf dot pow. Fabulous. And part 3 here, float part 3, and that's going to be 2 zeros. Okay, part 3 equals mathf dot pow. Pow. Okay, part 1 plus part 2, comma 1 divided by m1. Yikes. All right, and then return 1 divided by part 3. Gosh, how about that? How about that? Could you work that out? I hope you could. I couldn't have. But if we spin back to the thing here, that's what this is basically saying here. This is giving us that radius. So you see the 1 divided by bit, can't you? 1 divided by r. So that bit part 3 must be r, and we're returning 1 divided by r. Oh, okay, I'll get that bit. So that's going to give us our radius here. And then what have we got? I mean, we could give this a try, couldn't we? We've just created our very simple things up here. Gosh, here we go. Any errors? Let's just console clear. Stop it and run it. Guys, look at that! Look at that! I don't know if this is going to work anymore because we're not tying it to anything. Let's hide those positions. That's annoying me. Okay, so we could. What could we do? What can we do? Let's just try a few values for m, shall we, and see what happens. So I'll make m the slider now. Create SuperEllipse slider.value, and m. Now what we need to do? Create SuperEllipse. What we could probably do now. What do we set? We're sending in the angle. That SuperShape is there. So create SuperEllipse. N is no longer good to us, is it? Can I just take a chance? Is it even up there anymore? No. So let's just remove that. Still good. I'm assuming this bit up here will fail because it's got slider.value. We're still good. I like to go into Unity to check the errors because MonoDevelop doesn't always show you. We're still good. Let's just give it a quick run. Good. And now what we can do, if we just say M up here, we'll say M equals slider.value. Okay, and what I'll do, is that good? Yeah. Fine, and then because it's going to create it on the first go. So save that, and we'll go back into here. Let's stop it, and initially on our line renderer, on our slider here, we'll set the initial value to 5 now. All right, and let's run it. And if we do this, come on, look at that. Ooh, it's doing some weird things. And if we go down, it's going more. Oh my goodness. Whoa! Oh, when it's 0, it does that. Look, it's a nice circular thing. But as we go down here, I'm not 100% sure if it's right. It looks like it could be right. Let's try. I love that. That's very cool. All right, that's for M. What we could potentially do is these N values, N1, N2, N3. If I spin back to here, not here. Back to here. No, back to here. So these are the values for M, look. M's 3, M's 4, M's 5. Well, let's have a look. Let's try M is 4. So you've got to set N1, N2, N3 to 0.3 though, look. So let's just try that. That's a bit annoying. 0.3, 0.3, and 0.3. Now let's run it again. Oh yeah. Oh my goodness. And that is actually, I think, what I was kind of expecting. Wow. Doing some pretty crazy things, isn't it? But it's working. Way! And 0 is, of course, the circle. Well, of course, again, is the circle. But as you go up, it just starts to freak out. Oh, people, I love that. Okay. Let's just zoom in on here because that's just annoying, isn't it? Actually watch it in the scene view. Now this is something you could play around with all day long, isn't it? You could just sit there just doing this. I wonder if what's this one? N1 is 40, N2 and N3 are 10. So what we could do? I could make it. What I'm thinking is, shall I make it so that there's some things here we can do and just click go? But I'm just for now. Maybe something you could do. So we've got N1 is 40. N2, N3 is 10. That doesn't look much fun. How about, here we go, N1, N2, N3 is 0.3, and angle phi needs to extend from 0 to 12 pi. Angle phi needs to extend from 0 to 12 pi. So let's have a quick look here. If we change it down here, I think 12 pi? Maybe that's what it's saying. Let's try it. Did I save it? Never. Oh, not that. I did. We can hear it, run it. Yeah. Oh my god. There, look there. Is that what sort of thing we're seeing here? We can expect that. Yeah, I think if we were to tweak the value slightly. So what we could do. M is 13 over 6. That's annoying. Is that these ones? So let's try it. So move starfish, a value of 1 and 2. Oh, I wonder. Anyway, so you can play on and on and on. Here, look at that. There's some code there for the SuperShape. Yeah. Well, I never. So I was copying that there, but that's fine. This is really cool. I like this and I can play with it. But the good news is we're starting to get somewhere where we can create this in 3D. Okay, so as it moves around, the sort of M value increases, so it's going to create these weird shapes as it moves around and goes up. Ta-da! That's just I don't know what that is, but I hope that's been useful. I hope that's been enjoyable. It's the first part. Next part, we're going to get very serious and do something in 3D. It's going to hurt my brain. We're going to have to talk about latitude and longitude. Again, there's going to be some maths in there that you and I both aren't going to understand, but hey, we'll have a damn good try trying to understand it and enjoying it at the same time. So thank you ever so much for watching, guys. I seem to be up to about 370 subscribers now. I can't believe my luck. The fact that you guys are watching it, I think enjoying it, gives me really, really great pleasure. So again, please feel free to comment, like, subscribe, do whatever you like. I love hearing from you guys back, just to see how you're getting on. I heard that somebody's teaching their 9-year-old coding, which made me very proud. I've got a 10-year-old boy myself, and he enjoys a bit of coding. I'm not sure he'd be doing this one today, but he does enjoy coding. So thanks everyone for watching, and catch you soon. Cheers now. Bye bye.